Welcome to Economics Workshop. In our tutorial today, we'll be looking into optimization of economic function. Optimization of function. Optimization is the process of finding the relative minimum or maximum of a function. Steps in optimization of a function. Step 1. Take the first derivative, set it equal to 0, and solve for the critical point, which is the necessary condition. Step 2. Take the second derivative, evaluate it at the critical point, and check the signs, which is the sufficient condition. For relative maximum, f prime of evaluated at the critical value must be set equal to 0, and f prime prime evaluated at the critical value must be less than 0. For relative minimum, the first derivative must be set to 0 in order to get our critical value, and f prime prime evaluated at that critical value must be greater than 0. Note, f prime prime evaluated at the critical value equals to 0. That means when the second derivative evaluated at the critical value is equal to 0, the test is inconclusive. Take successive higher order derivative and evaluate at the critical value until the first non-zero higher order derivative. If the higher order derivative evaluated at the critical point is an odd number derivative, the function is at an inflection point. If the higher order derivative evaluated at the critical point is an even number derivative, the function is at a relative extremum. That means we can decide if there is a relative minimum or maximum. Thus, a negative value implies relative maximum and a positive value implies a relative minimum. Example 1. Given f of x equals to x raised to power 2 plus 16x. Solution. Step 1, we have to take the first derivative. F prime of x equals to 2x plus 16. So set it to 0. We have 2x plus 16 equals to 0. X equals to minus 8. That's our critical value or critical point. Step 2, take the second derivative and evaluate it at the critical point. F prime prime of x equals to 2. So f prime prime evaluated at minus 8 equals to 2. So since f prime evaluated at n equals to 0 and f prime prime evaluated at the critical point is greater than 0, the function is at relative minimum at x equals to minus 8. So that's how to do that. We can see that 2 is greater than 0. The f prime prime of 8 is greater than 0. It's a positive, so the function is at what? Relative minimum. Example 2, given f of x equals to 1 over 3 x raised to power 3 minus x raised to power 2 minus 3x. So we have to take the first derivative, which is x raised to power 2 minus 2x minus 3. Set it to 0. We have x plus 2 in bracket, x minus 3 in bracket equals to 0. So we are going to have two critical values here. So x equals to minus 1 and x equals to what? 3. So step 2, take the second derivative, f prime prime of x equals to what? 2x minus 2. Then evaluate this second derivative at each critical value. F prime prime evaluated at minus 1. So what you just need to do is to substitute that value of x in the second derivative. That is f prime prime evaluated at minus 1 equals to 2 open bracket minus 1 close bracket minus 2, which is equal to what? Minus 4. We can see this is negative, so we can say it is what? It is what? A relative maximum. F prime prime evaluated at 3, which is equal to 2 open bracket 3 close bracket minus 2. The answer for that is 4. We have a positive value here. You can say it is what? At relative minimum. The function is at relative minimum at x equals to 3, and it is at what? It is at maximum at x equals to minus 1. Example 3. Given f of x equals to 3x minus 18 all raised to power 3. Solution, take the first derivative. F prime of x equals to 3 open bracket 3x minus 18 close bracket raised to power 2 open bracket 3 close bracket. That will give us 9 open bracket 3x minus 18 all raised to power 2. So we have to set this to 0. We have 9 open bracket 3x minus 18 raised to power 2 equals to 0. Our x equals to what? 6. That's our critical value. So take step 2, take the second derivative. F prime prime of x equals to what? 18 open bracket 3x minus 18 multiplied by 3, which is 54 open bracket 3x minus 18. So we have to evaluate this second derivative at the critical value, which is 6. F prime prime evaluated at 6 equals to 54 open bracket 3 multiplied by 6 minus 18. The result of that is what? Is 0. So since f prime prime evaluated at the critical value is 0, we are to take a what? Higher order derivative. That means you differentiate the second derivative until we get the first non-zero value. So f prime prime of x will give us what? 162 when you differentiate that. Therefore, let us evaluate the third derivative at that critical value. F prime prime evaluated at 6 is equal to what? 162. Since the first non-zero higher order derivative evaluated at the critical point is an odd number derivative, that means f prime prime of n, the function is at what? An inflection point. You can see the first non-zero higher order derivative is evaluated at what? At an odd number derivative, which is f prime prime prime. So we can conclude that the function is what? At an inflection point. Example 4. Given f prime of x equals to x plus 4 all raised to power 4. Step 1, we have to take what? The first derivative and set it to 0, which is what? 4 open bracket x plus 4 all raised to power 3. Then set that to 0. X plus 4 equals to 0. X equals to what? Minus 4. That's our critical value. So we have to take the second derivative. F prime prime of x equals to what? 12 open bracket x plus 4 all raised to power 2. So that's the second derivative. Evaluate the second derivative at the critical value. F prime prime evaluated at 4 is equal to what? 12 open bracket minus 4 plus 4 close bracket raised to power 2. So the result of that is what? Is also 0. Since f prime prime evaluated at the critical value, which is minus 4, the result is 0, we are meant to take what? Higher order derivative. So we take the third derivative. F prime prime of x equals to 24x plus 4. Evaluate the third derivative at the critical value. We have f prime prime evaluated at minus 4 equals to what? 24 open bracket minus 4 plus 4 close bracket equals to what? 0. You can see we got 0, and I told you that is until we get the first non-zero higher order derivative. Since the result here is 0, you can conclude that the test is inconclusive. So we need to take higher order derivative. f prime of f iv of x, that means the fourth derivative, equals to 24 open bracket x plus 4 close bracket raised to power 0 multiplied by 1, which equals to what? 24. So the fourth derivative evaluated at the critical value minus 4, the result is 24. Now we have a non-zero value. Now since the first non-zero value is a higher order derivative evaluated at the critical point is an even number derivative, that means f iv n, the function is at what? Is at relative extremum. So since our result is greater than 24, the function is at a relative minimum at x equals to what? Minus 4. I told us in the previous slide, I told you that if the first non-zero value is higher order derivative is an even number, the function is at relative extremum. Therefore you can conclude whether it is a relative minimum or what? Maximum. And if the even number derivative evaluated at the critical value is greater than 0 is minimum. If it's less than 0, it is what? It is maximum. So this is how to optimize function. Like and subscribe to this channel. Stay tuned for more classes.